All right, so we have a rate equation here, and we want to derive approximate values for this rate equation, given that we have first a really high concentration of H2 and then a really low concentration. So assuming that the concentration of H2 is really high, and in this denominator, K2 times a really, really big number, we would assume is going to be much greater than the value of 1. So we can approximate the denominator as just K2 times H2 concentration, and then we have, for the same numerator, I suppose I can do like a curly equal sign to show that we're approximating. All right, now dividing by just that K2 over concentration of H2, this can cancel out on the top and bottom, and then we'll just have some ratio of rate constants times the concentration of NO to the second power, meaning a rate that's second order in NO and independent of H2 concentration, because if it's already really high, changing it won't make a difference. Conversely, if we have a really low concentration of H2, then multiplying it by some constant gives a really small number, so we might assume that 1 is much greater than K2 times the concentration of H2, and then we can just approximate the denominator as 1. So the rate will be K1 times the concentration of NO to the second power times the concentration of H2 over 1, which we can just get rid of the denominator because dividing by 1 doesn't mathematically change anything. And then we have rate constant times second order in NO and first order in H2. Hope this helps.